Hi, good evening. In the last session, we have discussed about object class and string class of lang packages. In this session, we are going to discuss about string buffer, string builder, and wrapper classes. So in the last session, as we discussed previously, string is mutable. In case if you want a immutable class, immutable string, then string builder, string buffer class provide mutable string. String buffer provides mutable string. So in string class, if you try to create a new object, with the change of the object, it will create a new object. So string is immutable. We cannot change the object. In case if you try to change, it will create a new object. We cannot change the existing object. If you try to change, it will create a new object with a change. But whereas string buffer is used to give mutable string. So we can change the object of a string using string buffer class. So string buffer provides a mutable string. How it will provide the mutable string? The string buffer class has a method that is append method. That is append method. See here, I have a method that is append test. So here I'm going to create a object that is string buffer object. String buffer as b equal to new string buffer. This is a way of creating an object. So string buffer is a class is available in Java lang package. So see here, Java lang string buffer. String buffer is a class is available in Java lang package. It's a default class provided by Java vendor. So I'm going to create a object for the string buffer. This is the object. Hello is my object. Now if I want to change the object, as of now the object is hello. Now I want to change the object as hello Java. Yes, I can change it using string append method, string buffer of append method. So the append method will append the string with other string. Now the object will change as hello Java. Initially, the object is hello. When you create a string buffer object, string buffer sb equal to new string buffer of hello. Now the object is hello. So when I use this append method, sb is a string buffer object sb.append of Java. Now the object will be hello Java. So we have changed the object. Now it's a mutable string. Hello Java is a mutable string. Whereas if it is a string, no, we cannot change. As we seen in the previous example, using concat method, string class has a concat method. Even we use the concat method, the object will not change because it's a immutable. String is a immutable, whereas string buffer is a mutable. We can change the string object. So in case if you require a mutable string, then we will use this string buffer instead of string class. And then string buffer is also similar to string, except is a mutable. The string is immutable, remaining everything is same. So here using the string buffer also we can replace and we can insert. So the string buffer class has a methods. Those are append method, insert method, replace, delete. These all other methods are reverse These all of the methods are available in StringBuffer class. So now let us see each class. And first let us check the mutability, string mutability. So now here this is the testing. We are testing the appending method, how we provide the mutable string. So let us call this method. So if I want to call this method, how can I call this method? First, I need to create an object for this string buffer method test. So here I have created an object string buffer method test sbt equal to new string buffer method test. So I have created an object for this class append test method. I'm calling append test method. How can you call sbt dot append test? Sbt dot append test. So when I call this method, now the object is changed to hello Java, run as Java application. See here, hello Java. So this is a code. So first this is hello, object is hello, and now we are appending the other string with string buffer object. Now the object is hello Java. So it's a mutable because we could change the object. Initially the object is hello. Then I have changed the object using append method sb.append of Java. Now the object is changed as hello Java. So it's a mutable. We can change the object using string buffer class. The string object. We can change the string object using string buffer class. And I have another methods. The other methods of a string buffer is insert is a method that is for here we have hello and then hello is an object sb.insert one is a parameter comma Java. Then what happens is it in first character it will print. After the first character it will insert the Java object. Now when you print it, so how it will print? H hello H. After first character Java will insert and remaining characters will as usually. So this is the output after the insert. And then replace. So from first to third character it will replace. In the hello, from first character to third character replace with Java. So H after H Java LO is a replace. You can use this replace in case if you want to replace any string with other string, then we will use replace method. Then delete method. If you want to delete string, we can delete from the character to the character, from which character to which character we want to delete. We can delete using this parameter, this method. SB string buffer is the object hello. From first character to third character, I want to remove it. Then from first character, ELL is removed and HLO will be the output. So first character to third character. It means in between two characters it will remove. And then this string buffer has a method that is reverse method. Reverse method. We can reverse the string using string buffer reverse method. The string buffer object is hello. String buffer sb equal to new string buffer. The object is hello. Now I want to reverse this object. I can reverse this object using reverse method of string buffer class. So sb dot reverse. When you use sb dot reverse, then it will reverse the string HELLO will reverse to OLLEH. So we can reverse the string using this reverse method. These all are the methods are available in this string buffer. The main advantage of this string buffer class is it provides the mutable string, whereas string class is immutable. We cannot change the object, whereas using the string buffer can change the object. So string buffer provides the mutable string. So let us check this reverse test method. So when I call reverse test method, so hello is my object, string buffer object. Let us see how it will print when you reverse it. See, OLLEH. It's reverse the string. So the main purpose of this string buffer is to provide a mutable string. And the next class is string builder. In string buffer, it's a mutable string, but there is some disadvantage in this string buffer. The disadvantage is all the methods in string buffer are synchronized methods. All methods are synchronized methods. As we discussed previously when we were discussing about threads concept, we have discussed about synchronized method. The synchronized method will allow only one object to execute that method. It doesn't allow multiple objects to execute concurrently. So then what happens here is, if there are multiple objects are trying to execute the same method, it doesn't allow, it will allow only one method, one object at a time to execute it. So the performance will be low. It gives the low performance. It will be very slow. But it's better than string object, because for string, for every change it will create a new object. So it takes more time. Compared to string, it gives better performance. The string buffer will give better performance. But still, because of these string, all methods, string buffer methods are synchronized methods. It's multiple objects cannot execute the same methods. So the performance will be low. So to avoid this issue, the Java vendor provided introduced other class, that is StringBuilder class. StringBuilder class. The StringBuilder class is also similar to a StringBuffer class. The difference between the StringBuffer and StringBuilder is StringBuffer class, all methods are synchronized methods, whereas StringBuilder class methods are non-synchronized methods, so that it gives the better performance compared to string buffer. In string buffer, all methods are synchronized methods. In string builder, no method is synchronized method, so that it will give better performance. So later we will see what's the difference between the string and string buffer, and what's the difference between string buffer and string builder. Before that, let us test the performance. How it will give the performance. What's the performance of string and string buffer and string builder in these all three, which will give the better performance. Let us check the performance. So for checking the performance, I have written a class to check the performance. So after we check the performance, we will see what's the difference between these string buffer, and string builder. So the most important interview question, the differences between the string and string buffer and StringBuffer and StringBuilder. So first let's check the performance, which will give the better performance. So for performance test, so I have already written the class for testing the performance. So here I have written a class that is performance test. So here I'm checking the string object and string buffer object, which will give the better performance. Whether string will give the better performance or string buffer will give the better performance, which will give the better performance. I'm checking here. So for checking, what I'm doing here, I have created a string object, string t equals Java. String t equals Java. It's a string object. It's a string object. Now what I'm doing here is I'm adding, it means I'm concatenating the class, I'm concatenating the class with Java for 10,000 times. For 10,000 times I'm adding the class for Java. So Java class. So it will be like 10,000 times it will add to Java object. So here, how much time it will take to add the class string to the Java string? For 10,000 times, it will calculate it. So for calculating it, we will see the starting time and the ending time of the method. So when you start this method, we will see the time, and after ending this method, we will see the time, and we will subtract the current time with starting time so that we can get the exact milliseconds, how many milliseconds has taken to execute this method. Similarly, I'm creating other method, that is StringBuffer object. So this is string object, string t equal to Java. So here I'm creating StringBuffer object, that is Java. And then for StringBuffer object also appending this class for 10,000 times. 10,000 times. So both string and string buffer, both classes, string and string buffer, both classes are appending other string for 10,000 times. So then we can check it, which object, which class appends early. So which class is taking and how much time we can check it here. So for checking it here I have created one variable, that is start time. The start time will be system current time milliseconds. So system is a class. System is a class is available in Java lang package. So the system class have a method that is current time milliseconds. It will take the current time in milliseconds. And then here I'm calling concat with string. I'm calling concat with string. When concat with string, this method will call. When this method call, it will concat for 10,000 times, and then after concating this 10,000 times, here time taken by concating with the string, system dot current time milliseconds minus start time. Then the current time minus start time. The start time, this is the start time, and then current time. So when you subtract this start time from the current time, then we can see how many milliseconds of the time has taken to execute this method. And then similarly, after executing this method, again the start time, we are taking the start time and then concat with the string buffer. Then this method is calling. This method is calling. When call this method, then time taken by concatenating with the string buffer, the system current time minus start time, then it will give the exact time taken to execute this method, string buffer object. So now let us check which will take more time, which will take less time, which will give the better performance. Let us check whether the string will give the better performance or string buffer will give the better performance. Let us check it here. Just give the right click, run as Java application. See here, time taken by concat with string is 359 milliseconds, whereas time taken by concat with string buffer 2 milliseconds. See how much variance is there. There is much variance. Here it has taken 359 milliseconds, whereas string buffer has taken just 2 milliseconds. So string buffer is giving better performance. So within 2 milliseconds it has executed. So it has concatenated, this class has concatenated for 10,000 times within 2 milliseconds. Whereas the same string has taken 359 milliseconds. So string buffer will give the better performance compared to string class. Then similarly, string buffer and string builder. String buffer and string builder. So which will give the better performance, whether the string buffer class or string builder class. So now here I am checking string buffer and string builder. So for that, so first the start time. Here the start time, system current time, it will take it the start time as a start time, and string buffer sb equal to new string buffer Java, and I'm concatenating this for 10,000 times. So this is the for loop. It will loop for 10,000 times. It will append, keep append the class for 10,000 times. So this is string buffer. And then here we are calculating the time. So for calculating the time, so how we calculate the time? System current time minus start time. So the start time here, it will take the start time. So system current time minus start time, it will give the exact milliseconds of the time has taken to execute this code. And then immediately again we are taking the start time, and then string builder. String builder is a class. So this is also available in Java lang package. So I'm creating the string builder object. So string builder sb2 equal to new string builder. And similarly for here also we are concatenating, we are appending this class for 10,000 times. For 10,000 times. So both are appending for 10,000 times. String buffer object, for string buffer object also appending 10,000 times. For string builder also appending the 10,000 times. And here we are calculating the time has taken to execute the code, that is to append this string builder object. So now let us check which will take more time, which will take less time. Let us check it. So for checking, right click and run as Java application. See here, time taken by string buffer. So this is the string buffer. Time taken by this string buffer object is 2 milliseconds. 2 milliseconds. Then string builder, this is the string builder object. So here we are concatenating class for 10,000 times. Time taken by string builder is 1 millisecond. So this is 2 milliseconds. This is 1 millisecond. So both are concatenating, both are appending the class for 10,000 times, but string buffer has taken 2 milliseconds to execute that code to append for 10,000 times. String builder has taken only 1 millisecond time to append the object for 10,000 times. So when compare these three, string buffer and string builder, compared to string buffer will give the better performance. Compared to string buffer, string builder will give the better performance. So then when will we go for string, when will we go for string buffer, and when will you go for string builder? If you want immutable object, unchanged object, unchanged string object, then I will go for the string. If you want mutable string, it means you keep on has to change the string, then we will go for the string buffer. But here all these methods are synchronized methods. If you require the synchronized object, so which will allow only one object to execute it, then we will go for the string buffer. Otherwise we will go for the string builder, because the string builder will give better performance. So depend on requirement, depend on situation, we will use these classes. Then we'll see what's the difference between the string buffer, and what's the difference between string buffer and string builder. So to see the difference between the string buffer and string builder, so the string class is immutable. The string class is immutable, which we cannot change the object. And string is slow and consumes more memory when you concat too many string, because every time it creates a new instance. So as we see in the performance test previously, string is slow and consumes more memory when you concat too many strings, because every time it creates a new instance. Instance means object. And then in string class overrides the equals methods of object class. A string class overrides the equals method of object class. So you can compare the content of two strings by equals method. We can compare the content of two strings using equals method. Then what's the string buffer class? String buffer class is immutable. String class is a immutable. String buffer is mutable. We can change object. We keep changed object. And string buffer is fast and consumes less memory when you concat string. So when you compare to string buffer is faster and consumes less memory. And string buffer class doesn't override the equals method of your object class. It doesn't override. So it uses directly the object class. It doesn't override it. So these three are the differences of string and string buffer. String class is immutable, which we cannot change the object. String buffer class is mutable. String is slow and consumes more memory, whereas string buffer is fast, it consumes less memory. And string class overrides the equals method of object class, so that we can compare the content of two strings, whereas string buffer doesn't override the equals method of the object class. This is the difference between string and string buffer class, string class and string buffer class. And then the next question is, what's the difference between string buffer class and string builder class? The difference between string buffer class and string builder class is there are only two differences. Those are string buffer is synchronized. String buffer methods are synchronized methods. All methods are synchronized methods and thread safe. It's a thread safe. It will allow only one object to execute this method. It means two threads can't call the methods of string buffer simultaneously, concurrently. And string buffer is less efficient than string builder. So as we see in the performance test, string builder will give more performance. Then string builder is non-synchronized. String builder is all methods in string builder is non-synchronized methods. All are non-synchronized methods. So there is no thread safe. So multiple objects can execute the same method concurrently. Then string builder is more efficient than string buffer. String builder will give the better performance compared to string buffer. So these are the differences between the string and string buffer and string builder. And the next concept in Java lang package, wrapper classes. What are the wrapper classes? So when we define the variables, we define the variables as a primitive types. Those are int, float, double, long. These all are the primitive types. These all are primitive types. So these all are not objects. These are not Java objects. This is a primitive type. If you want to convert these primitive types into object, if you want to convert these primitive types into object, then we will use wrapper classes. We'll use wrapper classes. So converting the primitive type into object is a wrapper class. So we'll have a wrapper classes. For each primitive type have a wrapper class. Those are int has a wrapper class that is integer. Int has a wrapper class that is integer. So here we have a data types. Those are int. The wrapper class for this primitive int type is integer. Integer. So and then we have other wrapper class that is float. The primitive type, the wrapper class for this primitive type float is float. See, these all are classes, so that the first letter must be the capital, integer, float, and then double. For double is a primitive type, then the wrapper class is double. The only difference is here for integer, for float, so it's a similar to a wrapper class. Since it is a wrapper class, the first letter is capital letter. For double, so it's a primitive type. It's a primitive type. It is wrapper class. Since it is a class, the first letter must be the capital. And then long is a primitive type, and the wrapper class is long. Is a wrapper class. So every primitive type has a wrapper class. Every primitive type has a wrapper class. So we can convert this primitive type into wrapper type as a object, as a Java integer object and float object, which we called as auto boxing, and which will convert this from this wrapper to primitive type, call it as a auto unboxing. So how we will convert it is, we have a method that is instance of method. Using this instance of method, we can convert this primitive to wrapper. So here have a class that is primitive to wrapper. Here what I am doing here is, I have primitive variable, primitive type int a equaled 100. It is a primitive type. Int is a primitive type. Now I want to convert this primitive type into wrapper. So if I want to convert this primitive into wrapper, then I will use value of method. A is the variable, so integer dot value of a. So then it will convert into the wrapper type as a integer object. Then we are saving into this integer I. Now again I can assign this integer j equal a. It is we call it as auto boxing. So now what happened here is, when you assign the value directly here, the auto boxing, the Java compiler will write internally the integer dot value of a. So whatever we are writing here as a programmer, here we are writing the same. If you do not write, if you assign directly, then the Java compiler will write this code internally. So that we call it as a auto boxing. What is the auto boxing? Converting a primitive type into wrapper type, call it as auto boxing. But object is same, but we are converting from primitive type to wrapper type. So here I'm printing the value of a. So this is the value, and I value and j value. So let us see how to execute it, run a Java application. So here a value, I value, j value, all values are 100. So this is a primitive type. If you want to convert this primitive type into wrapper class, object, this integer is a direct object. If you want to convert this 100 into object, then we'll use integer dot value of a. It's a wrapper. In case if you do not convert this, if you assign directly int j equal to a value is 100, then the Java compiler internally will write this code. And then it will convert into this wrapper class. This mechanism we call it as a auto boxing. Then similarly, if you convert from wrapper to primitive, we call auto unboxing. Now we are converting from primitive to wrapper, so this is auto boxing. If it convert from wrapper to primitive, then call it as auto unboxing. So here I am creating an integer object, integer a equal to new integer of 300. It's a object, integer object. So if you want to convert this integer object into a primitive type, then we'll use this init value method, a dot int value of this method. When you use this method, then it will convert into int value as a primitive type. Now the primitive type of I value is 300. In case if you do not write this int value method, if you assign directly this a for this primitive type, then internally Java compiler will write this code. So this mechanism we call it as a auto unboxing. We call it as a auto unboxing. Previously auto boxing, automatically it will converting. Now it is unboxing, from wrapper to primitive it is converting. So we call it as a auto unboxing. So let us execute it. Yes. So here a value is a 300 and I value is also a 300 and j value is also a 300. So this is for today. Our Java lang packages are completed. In tomorrow's session, we will start the collections concept. It is more important in core Java. So don't miss it to attend for collection concepts. So we'll start the collections concept from tomorrow. You don't miss it. This is for today, and then we'll see you in the tomorrow session. Until then, take care. Bye bye. Good night.